Hello students, today we are going to study about EMF and terminal PD. This is a topic in current electricity, a basic topic in current electricity. We always hear a word called voltage, okay? That is a very generalized term. In physics, we very often use the word PD. PD is potential difference. Now, what is this EMF? EMF is electromotive force, but really it has nothing to do with force. It is also energy. We are going to study about all this interconnection in this video. For example, let me take a case of a cell, right? Let me take a cell. It can be any cell. Electrochemical cell, electrolytic cell, it can be Daniell cell, it can be Lagrange cell, or it can be any type of cell. Yes. What a cell consists of basically? It consists of a liquid or little semi-solid, let us say, which is called electrolyte. You call it as electrolyte. It's a solution. It can be anything. Okay. We can take any solution for that matter, like H2SO4, okay, and we can take some other chemical with that and we will get it. And we place two plates inside that, and these plates are called electrodes, okay. This is called electrode, okay, there are two electrodes are there, and this is called electrolyte, okay, electrolyte, it's a solution. Now, what actually happens is, when we connect this to, let us say this to a wire, to a cell, let us say. It's a cell actually. When I connect it, let us say to a bulb. Let us assume I connect it to a bulb. Now, what is going to happen really? One terminal will become positive and another terminal will become negative because of redox reaction, reduction and oxidation. In one of the electrode, reduction action will take place, in another you will be oxidation action will take place. We can take for example a simple plates also like copper and zinc. We can take copper and zinc, two different, and H2SO4 is there. What will happen basically? Zinc will break into zinc 2 plus and 2 electrons, and copper again can also break into copper 2 plus with 2 electrons. Now when you talk about H2SO4, it can break into H plus and SO4 2 minus. So these are all nothing but ions. The movement of ions inside the cell, that is very important, which produces electricity. See, the electrons are going to flow through in the external circuit because they dissociate inside the electrolyte and they get attached to one of the anode, either anode or cathode, that is the electrodes which are going to call it positive or negative, and the electricity comes out and the bulb glows. In current electricity, we take positive terminal to negative terminal, the conventional current as the current direction, that we represent by the symbol I. But in reality, it is electrons which are going in the opposite direction, but that is outside. With this concept, you have to understand that inside the chemical also, inside the electrolyte also, the electrons have to move. The electrons, they have to move in between the ions. That produces a resistance. That means when they hit each other, it produces an opposition. And that resistance, we call it as internal resistance. We represent by small r, our internal resistance. And the bulb I connect outside, that is called external resistance. These are all lot to do with the chemistry. Now we simplify the whole circuit and see what is going to happen. So whenever we talk about things, two things we have to remember. One is external which is a bulb or any object, and internal, which is produced by the cell itself. Okay, now let me erase this part of it because this is only an introduction. Fine, and I am going to take really a cell and a circuit, a small simple circuit let us take. Okay, what a simple circuit consists of? A simple circuit consists of a cell. One is a long one and which is positive, and there is a short one and we represent as negative. There is a cell and I connect this cell to an external resistance, that is capital R, and the cell inside has resistance, and that resistance is internal resistance small r, and I am taking it out like this. I told you the potential difference between the two ends of the cell, if I say as V, or I can measure potential difference between the two ends of the conductor or the resistance. If I take this point as A and this point as B, right? And what I measure in between this, that I measure it using a voltmeter. I measure with the help of a voltmeter which is connected parallel to the resistance. And I always connect an ammeter which measures current in series with the circuit. And anywhere you can introduce a small key, right? Or you can introduce anywhere a switch, right? That is there. Now, what the cell is going to give is called EMF. EMF is, again, it is a potential difference between the two ends of the cell, between these 2 points, right? Now, no current is flowing. The switch is off. The switch is open. We are not still close to this. No current is flowing through. At that time, what the cell is going to give, that is called EMF. So, according to Ohm's law, right? What does Ohm's law says? Ohm's law says V is proportional to I, or V is equal to R into I, where R is the resistance, which is the external resistance, and what I measure in between this is potential difference or terminal PD, whatever you want to call it. Now, we introduce the term called EMF. EMF is no current is flowing through. When no current is flowing through, then I can write the EMF is proportional to current. What I should write? EMF. EMF is proportional to current. Don't break it. Electromotive force. No, it is EMF, right? And EMF will be proportional to what? It includes, EMF includes the external resistance plus the internal resistance, right? And it will be proportional to R plus small r into I. Okay? Now, watch carefully here. I can say from this, I is equal to V upon R. Okay? First equation, I is equal to V upon R. Fine. And in this equation, I can say it is equal to, it has become I is equal to epsilon upon R plus R. Remember very clearly, when I talk about EMF of the cell, no current is flowing through outside. The cell has everything inside, right? And that will be greater. Usually, the EMF will be greater than the potential difference, because internal resistance also will take up certain amount of current, or through that it will pass through. Now you understand these 2 points. One is I is equal to V upon R, and I is equal to epsilon upon R plus R. Call this as equation number 2. Now we can compare these 2 equations very easily, right? And we get equation for internal resistance. Both currents are same. Let us switch it on now. From positive, the current I is flowing through, the I is flowing through, the I is coming back, which I can measure it in the ammeter, right? So, first equation, V upon R is equal to epsilon upon R plus R. Okay? Now, let us cross multiply these 2 terms. R plus R divided by R is equal to epsilon upon V. Fine. From here, I can say, right, R upon R plus small r upon capital R. I break it into two parts, that is epsilon upon V. R by R is 1, 1 plus R upon R is equal to epsilon upon V. Or I can say R divided by capital R is equal to epsilon upon V minus 1. Or internal resistance is equal to epsilon upon V minus 1 into capital R. So this is how you can calculate the internal resistance of the cell. Now I wanted to make it little bit more understandable. This equation you can derive very easily by making the comparison. For your understanding, in a different way, let me approach the same concept, because understanding EMF and PD is the most important thing. Now see, let us say epsilon is the total potential difference supplied, or the total energy supplied by the cell, and that is used for two purposes. One, as a potential difference between the two ends of the resistance, external resistance, plus V dash I will put it. What is the small V dash? Or I can simply say small v. What is the small v? This is what is the potential drop inside the cell. You call the word potential drop. Okay, so that is epsilon is equal to, according to Ohm's law, I into R. Okay, that is I into R plus, you know, in series the same current is flowing through, right? I into the internal resistance. I have just taken it for reference outside, so into R. That is I is common, so R plus R, which is epsilon, or I said I is equal to epsilon upon R plus R. Whenever you talk about epsilon, the EMF, then you need to include the internal resistance. Be very clear about it. I am going to draw a simpler diagram. See, let me erase this whole diagram. For our understanding, I can draw it in a different way. You can see this, we do it in experiment. Okay. And now I got a cell here. One is positive terminal, long one, and the short one is the negative terminal. Fine. And now let me connect from here to a bulb. Okay. So the bulb is the external resistance. Now current is flowing through. Current I is flowing through. The current is coming back here. Right. And what I measure between these two, this is the resistance which I am calling. Fine. Now what this gives you is epsilon, full value. Right. Now if current is flowing through, what I measure between these two is called potential difference. Then internal resistance will come into the play. But if there is a switch, let us say, I place a switch here. Let me take a tap switch, right? And the switch is open. That means I did not close. So no current is flowing through. When no current is flowing through, what you measure that between these 2 points, that is called EMF, right? That is the total energy. And the moment I close it, fine, I close it and the current is flowing through that, I close it and the current is flowing through that, positive to negative, what will happen? It will be, there will be a small drop in potential inside the cell. That is internal resistance. That is why when you measure, you have to measure the external resistance and potential drop across the internal resistance. That is the total value. I hope you understand from all these concepts, right? And you see the notes also, you will understand better. Thank you so much.